Hello everyone, this is Ketisha. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Foundation Tier from 2021. Question number 3 is on the topic of forces, mainly to do with stopping distance and reaction time and thinking distance. The stopping distance of a car is the sum of the thinking distance and the braking distance. The thinking distance is affected by the reaction time of the driver. Which two of the following can affect the reaction time of the driver? Tick two boxes. Now, the reaction time of the driver is going to be affected by anything to do with the driver itself. So, damaged tires is to do with the car. Taking drugs is to do with the driver. Tiredness is to do with the driver. Wet roads and worn tires is not going to affect the thinking distance. Scientists measured the reaction time for drivers of different ages. Figure 6 shows the results. So you have the mean reaction time in seconds on the y-axis and the age of driver in years in the x-axis. At what age did the drivers have the lowest mean reaction time? The lowest mean reaction time is over here. And that age is, so from 15 to 20, that's 5 boxes. So 5 divided by 5 is 1. So each box is 1 year. So, and that's 1 box short of 25. So that would be 24 years. What is the lowest mean reaction time? So what is the lowest mean reaction time? It's actually this point, which is right in the middle of here. Again, how do you work out the scale? Each box is 0.1. So it's going from 0.5 to 0.6. So there's 5 boxes. So 0.1 divided by 5 gives me 0.02. So halfway between, this is going to be 0.55. 0.55. Now they would accept answers between the range of 0.54 to 0.56. The braking distance of a car is the distance traveled between the driver applying the brakes and the car stopping. Complete the sentence, choose the answers from the box. Each answer may be used once, more than once, or not at all. When the brakes are applied, the kinetic energy of the car decreases because it's slowing down. The temperature of the brakes increases. Thus, due to friction and work is being done against the motion of the car to slow it down. The driver is traveling at a speed of 12 meters per second. The driver applies the brakes and the car decelerates at a constant 3 meters per second squared. Calculate the braking distance, use the equation. So they have given you the equation and choose the unit from the box. So braking distance equals the speed squared, that is, speed is 12 squared divided by 2 multiplied by the deceleration, which is 3. So let's 12 squared is 12 times 12, which is 144, divided by 3 times, or 2 times 3 is 6. So what is 144 divided by 6? Let's bring in the calculator. So 144 divided by 6, that gives me 24. 24 So the braking distance is 24 and distance is measured in meters. And you get 1 mark for that and 3 marks for the correct answer here. To pass the UK driving test, people must know the typical stopping distance of a car at certain speed. Suggest one reason why. So why is it a good idea to know the typical stopping distance of a car at certain speeds? So let's say you're driving at a 20-mile zone in front of a school. How far should you be behind the car in front of you? And if you're driving in the motorway at 70 miles per hour, how far should you be behind the car in front of you? That distance is different, right? Why should you know the typical stopping distance? To know how far behind you should be driving in case the car in front stops suddenly. That brings us to the end of question number 3, and I will see you in question number 4.